Hello guys, welcome to another section of Math. I believe you guys are doing good. This indefinite integral question here looks a little bit scary. Yeah, indefinite integral of maybe 1 over square root of 16 minus 4x squared times sine inverse of 1 over 2x. Yeah, it's a little bit scary. If you come across it for the first time, you might say, this problem, I wonder what is going to be the solution to this problem. It's going to entail a lot. That is, you'll be thinking is what? Very difficult to what? Tackle. Because even sine inverse of 1 over 2x is not all that easy to integrate. And here is the case we are having square root of 16 minus 4x squared being multiplied by sine inverse of 1 over 2. Yeah, I hope or I believe some of us will be thinking that this problem here is very difficult or maybe requires some very complex approach to solve, or we're going to use some very maybe some kind of special or unique approach to solve this problem, but actually it's not. You remember in the other video I said that the moment you get problems of this nature, the first thing that you should think of is what approach should I use? If I'm to work this solution out, what approach should I use? The moment you figure out the approach, it becomes what? Simple. Yeah, it becomes what? Simple to what? Tackle. Because if you don't know the approach, you won't be able to what? Start anything. But if you know the approach that you are going to use, definitely knowing the approach will also what? Help you know how you are going to apply the approach. And if you know how to apply the approach, definitely you're going to get your what? Answer at the end of the day. Okay, so first of all, I don't want you to, be thinking that this problem here is difficult. No, it's not that difficult. The most important thing here is to figure out the approach. And when you figure out the approach, then you yourself will decide how to use the approach. Nobody will decide for you. If you think you're going to use partial fractions, you will decide how should I apply a partial fraction to solve this one. Okay, so the most important thing, as I said earlier on, is what? The approach, how to come out with what? The approach. Okay, so to eliminate the idea of this problem being difficult, or maybe thinking of what will be the solution to this problem here, let's get started so that you can get to know us everything, or you can get to know how this problem is solved. So Okay, so first let's write our solution. All right, let's bring it down here. Where we are going to solve the problem. Okay, indefinite integral of 1 over square root of 16 minus 4x squared times sine inverse of 1 over 2x dx. As I said earlier on, even when you look at this, you might think it's very difficult. Even the way it is what appearing, still you think it's what difficult. But the moment we figure out the approach, you could see, oh, it's not that difficult as we were thinking it is. Okay, so to solve problems of this nature, I'm not saying the approach that I'm going to use is the only way of what solving this problem. Okay, here I'm going to use only one approach. I'm going to use one approach to what solve this problem, but maybe you can come out with maybe one or two approaches that can help you solve this what problem. Maybe yours you can use maybe the approach that I'm going to use in this video plus another approach to solve. Maybe yours you can choose to not to use the approach in this video but rather what use a different approach, which at the end of the day will what give the same answer as this one is going to give, right? So the most important thing is to just figure out the approach. Okay, so this problem here we are going to um, solve this problem here using what? Substitution. Using substitution. Yeah, now we have been able to come out with the approach, but how is the substitution going to be what? Done? What are we going to substitute the variable that we are going to use for? Are we going to substitute this one for u, or are you going to take this one for u? Well, it all depends on how you want or and how fast you're gonna go. It all depends on you. Okay, but here I'm not going to rush. I'm just gonna take my time and work out the solution in bit for you guys. Okay, so first as I said, we are going to use the substitution approach. So that is the substitution here. So how are you going to do the substitution? Are you going to let u be equal to the square root of 16 minus 4x squared, or the sine inverse of 1 over 2x, or maybe 4x, or what? Well, here, this is how I'm going to work it out, or I'm going to apply the substitution. First, I'm going to take this 1 over 2 off. In the other video, we were able to rewrite what was in the square root in such a way that what is in the square root and what was in the trig ratio what became the same. So when we did the substitution, both sides was affected at once. But here, and we didn't bother what substituting the value of what x into the square root and then solving from there. But here we are not going to rewrite this one to get this, and then before we do the substitution. The other part I did that one. So in the other video, sorry, I did that one. So here I'm not going to do that again. What I'm going to do is that I'm going to take away this one and then find what is going to replace x in the u world. And when I get to this square root sign, or where we are having the square root, I'll just substitute x for u. Whatever that I'll get for u, I'll just substitute x for u, and I will show you how to substitute the variable into what the square root sign and how to what deal with it. Okay, so here I'm going to first take off this one because maybe when we let, you can also let u be equal to the whole of sine inverse of what 1 over 2x, provided you can deal with what the derivative. Yeah, you can deal with what the derivative. What I mean by that is when you are differentiate to find what is going to replace dx, provided when you are differentiating sine inverse of 1 over 2, you will be able to do it without any difficulty. Okay, now here, to make it simple and to avoid any confusion from here, I'm just going to work out with this. So you're going to first let u be equal to this one, so that the sine inverse of u will be very simple for us to what differentiate. Okay, so let's do a substitution. U is equal to 1 over 2x. Now let's multiply both sides by 2. And when you do that, you're gonna get 2u is equal to x. 2u is equal to x. Now let's differentiate this one. Let's differentiate. Now when you differentiate this, you're gonna get over 2 du, and when you differentiate this, you're gonna get dx. So 2 du is equal to dx, or dx is equal to 2 du. Okay, good. Now when we enter the u word, we are going to replace dx with what 2 du, and we are going to replace x with what 2u. So when we go to where we are having the square root sign, where you see x, we will just put this one there. And then when we get to where we are having the sine inverse of half of x, you will just replace this half of x with what u. Okay, good. So now let's replace them. Good. Now in the u world, that is how the question is now looking like in the u world. Now after replacing them, we have got an indefinite integral of 1 over square root of 16 minus 4. Remember in the x world, here was what x squared, but because we have moved from x world into u world, what is replacing x? That is when you come here, you see that x is equal to 2u. So instead of writing x here, we decide to write what 2u, because 2u is equal to what x. Okay, and remember it was being squared, so that's how come we have 4 into bracket 2u all squared. Now multiply by sine inverse of, it's supposed to be what half x, but half x is equal to a u. That is why this u is here. Now dx is equal to this one. That is why this one is also what here. Okay, so the whole of this times 2 du, what are we gonna get? We are going to bring these two at the back here, and then we focus on here what is inside the integral sign. Now mind you, 2u all squared will give us what 4u squared. 4u squared. Okay, and 4u squared times 4 will give us what 16u squared. 16u squared. Okay, good. Here what we are going to do here is that we are going to sorry, we are going to factorize what is inside the square root. That is 16 minus 16u squared. 16 minus 16u squared. Let's leave this one for now. That is sine inverse of u. Let's leave this one for now, and let's concentrate our attention on this side. How are you going to factorize this one? Here we are having 16, and here also we are having what? 16. So this one, when you factorize, you're gonna get square root of 16 into bracket 1 minus u squared. 1 minus u squared. And remember, the multiplication law of what said root a times root b is equal to root a is equal to root what? AB. So when we are having root AB and we want to reverse, it's going to be root AB is equal to root A times what? Root B. So here having square root of 16 into bracket 1 minus u squared can be written as square root of 16 times square root of what? 1 minus u squared. Okay. Alright. Okay, so here we are having now square root of what? 16. When you expand this one, this dot this here, this one means what? Multiplication. So when we multiply this by this, it's just going to be square root of the whole of 16 times what? This one. Okay. So when you split it, that is what you are going to get. Okay. Sometimes when it is of this form, you take it back. That is square root of what? 16 minus what? 16 u squared. And sometimes when it is given in that form, you just reverse it as this one is what? Showing. Okay. Now, square root of what? 16. When you square, somebody may be thinking you're gonna get what? Absolute value of what? 4. That is plus or minus of what? 4. But here I'm just going to avoid that. I'm just going to make it as 4 raised to the power 2. And the value of this square root sign is what? Half. So it's going to be 4 raised to the power 2 times 1 over 2. And when you do that, the 2 and the half will cancel out, and to give us what? 4 raised to the power 1. And 4 raised to the power 1 is what? 4. Okay, so here looking at the way I did it, or the way I looking at the way, or looking at the way I did this one, there's no way you are going to get plus or minus what? 4, because here we didn't take the square. We didn't write as square root of 4 is equal to, let's say, square root of 16 as what? 4. No, I didn't do it that way. I just want to avoid the plus or minus blah blah. So I just make it as what? 4 squared. 4 squared, and the square root sign took away what? The power 2. So what is left? It left is what? 4. So again, I guess what? 4. I'm saying this because somebody may think that when you square, you're gonna get what? Absolute value, that is plus or minus of what? 4. And maybe thinking that, when we take the plus, sometimes you can also take what? The minus as well. Or maybe can even think of, maybe your mind, I will just take the minus one and use it to solve the problem. Well, that is your own risk. You can do it that way. But me, I just want to avoid that. I just want to avoid that. So that is why I solve this one with what? Indices, and that will give me my positive what? 4, so that the so that confusion will reduce. Okay. So this one will just give us what? 4. As I said, 4 raised to the power 2, and the value of this one is half, so it's going to be 4 raised to the power 2 times 1 over 2. And the 2 and the half will cancel out, and to be left with what? 4 raised to the power 1. 4 raised to the power 1 is the same as what? 4. Okay, so here I'm gonna get 4. Good. This 4 here is constant. So I'm just gonna bring it at the back here once again. But mind you, is the denominator's position. So when we bring it out, it will be what? 1 over 4. 1 over 4. And the moment we bring it out, it will multiply this 1 over 2. Sorry, to multiply this 2 here. Okay. So you're gonna get 2 times 1 over 4 indefinite integral of 1 over square root of 1 minus u squared times sine inverse of u du. Okay, here these 2 can go into this 1, 2. So here you're gonna get what? 1 over 2. So you're gonna get 1 over 2 times what? This one. Alright, now we've managed to deal with take away what the 16, which was what maybe scaring us. So now the square root, what is inside the square root is now 1 minus what? U squared, and it's multiplied by sine inverse of what? U. Good. So here what are you going to do? And here to, after multiplying this by this, we had 1 over 2, and there is nothing that we can do to it again. Okay, so here what are we going to do? What other approach can we use? Should we write this one as into bracket square root of 1 minus u squared raised to the power minus 1, or what? Yeah, how? Yeah, we can do that. And when you do that, you still haven't done anything because the problem isn't yet solved. So when you do that, you still haven't done anything. So what are you going to do here? Well, you're going to do another substitution. Let's look at this one. Let's assume this one is not there. When we look at 1 over square root of 1 minus u squared, and we are to integrate this one alone without this one here, it's actually going to give us what? Sine inverse of what? U. And if you want to know why, you can use the trigonometry approach only for this one. If you want to know the integral of 1 over square root of 1 minus u squared is equal to sine inverse of u, you use the trig substitution approach. And when you draw your right angle, you just here we are subtracting u from 1, so you just put the u 1 from 1 on the hypotenuse, and then you put this u on the maybe the opposite. Yeah, put it on the opposite, and then use to generate your ratios, do the substitution, and then integrate at the end of the day. You see, you're gonna get what? Theta. And what will be the value for theta? That is what? The sine inverse of what? U. Maybe if you don't get that, maybe it didn't spread the figure, the numbers and the variables well on the right angle triangle. Okay, so we know that the integral to this square root of 1 minus u squared is what? Sine inverse of u. And here is the case we are having sine inverse of u here. So it has made the problem very simple for us to solve, because if the integral of this one will give us sine inverse of u, when we reverse sine inverse of u, what are you going to get? You are going to get the same thing as this. Okay, so how are you going to reverse sine inverse of what? U? That is by what? Differentiating. So when we differentiate sine inverse of u, you're just going to get this one, assuming this. What I'm saying is what, based on assumption, assuming this one is not there. This one alone will give us for sine inverse of u. And if you want to get this one back after integrating, we just differentiate, and when we differentiate, you're gonna get what, this one, that is 1 over square root of what, 1 minus u squared. That is what we are going to get at the end of the day. So now that we know the answer to this integral, which is what, the sine inverse of u, and also know the answer to sine inverse of u in terms of differentiation, which is what, 1 over square root of 1 minus u squared, why don't we do another substitution by letting m be equal to this sine inverse of u here? The moment we let sine inverse of m be equal to sine inverse of u, then we differentiate, we are going to get the same thing as this one is what, as this one what here. And when we do that, probably to find what is going to replace the u, we have to do what, we have to what, multiply both sides by the denominator, which at the end of the day will go to the other side, and when it is substituted into the integral, definitely is going to take away what, this one, and our problem will be what, easy. Okay, so let's do another substitution. Let's find out if what I'm saying is what, true, or if it's gonna what, work out well. If it doesn't work out, it doesn't matter, then we try another approach. Okay, all right, there's no harm in trying, so there we shouldn't um worry about maybe giving it what, a try. Let's try, maybe it can work out. So here you're going to do another substitution. You're going to let m be equal to sine inverse of u. Why? Because we know that the derivative of sine inverse of u will give us what, 1 over square root of what, 1 minus u. And after differentiating, finding what is going to replace the u in the m world, definitely the denominator, which will be on the other side, will definitely what, multiply what is going to replace what, the u, which at the end of the day will take away what, this one here. Okay, so let's find out. So let's do another substitution. You're gonna let m be equal to sine inverse of u. Now let's differentiate. This one will give us the m, and this one will give us what, 1 over, here is u, here is u. So when we differentiate, the variable that's supposed to be appear is what, u, and not x. As you may be thinking, what we know is what, x, but here is the case, we have moved from x to what, u. So remember I said x word and u word, I like using them because the moment you hear this word, you mean that everything is about what, that particular variable that we are talking about. When you say if this one is x, generally sine inverse of x will give us what, 1 over what, square root of 1 minus x squared. But here is u. So since this one is u, we can't write x there. Okay, but we can't write x there because this one is not what, x, but what, u. And to prevent you from getting confused, that is why I always say u word, x word, blah 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 blah, so that you will know that instead of writing x, you just write what, u word there, just because this problem is in what, u word. Okay, good. So you're gonna get dm is equal to 1 over square root of 1 minus what, u squared. Here should have been x squared, but we are in what, u squared. The same thing, if this one is in if this one is another variable, it could have been another variable world. Okay, good. So you see what I was saying, dm is equal to 1 over square root of 1 minus u squared. This one is exactly what is in the integral what, what is inside the what? The integral. But when it is like this, we can put this one into what? The integral, because the m is actually equal to 1 over square root of 1 minus what? U squared. And we are moving from U world into what? M world. And going from U world into M world, everything has to be in what? U world. Okay? Everything has to be in what? U world. Okay? Unless maybe you decide to treat the variable that you are maintaining as what? Constant, maybe in terms of double integral, but we're not doing double integral what here. Okay, so to find what is going to replace du, we are going to multiply both sides by what? Square root of 1 minus u squared. And when you do that, you're gonna get du is equal to square root of 1 minus u squared dm. So when we go back to the integral, in the m world, du, we will replace it with what? This one. And then sine inverse of u will be replaced with what? M. Don't worry about what is going to replace square root of 1 minus u squared, because that one is going to be taken away. And that is the main reason why I didn't change this one into the u word, or find another thing to replace what this one is what? The m word, because this one here, we are having the same thing in the integral already. So that and this one is going to cancel out, and I have maintained it here because I want to show you what the cancellation or aspect. Okay, so now let's continue. All right. So when we put everything into the integral in the m world, that is what we are going to get at the end of the day. Now, this one, the u is equal to this. So this one in the u position will definitely give us what? 1 over square root of 1 minus u squared times m times square root of 1 minus u squared dm. And when you do that, that is what you are going to get at the end of the day. That is why I wrote it straightforward. Now we are in m world, and here is the case. We are not treating this one as constant. Neither are we going to find anything to replace this one in the m world, but this one is in the m world. But we chose to maintain it in the m world because of the cancellation aspect that we are going to do. So it's in m world, but not actually in m world, but just that because in a few seconds it's just going to get vanished. Okay, but so you don't worry or don't get confused. So here this one is the same thing as what this one here. So what happens? This and this will go away, and to be left with what? M, and here will be left with what? 1. So you're gonna get 1 over 2 in the first integral of what? 1 over m dm. Yeah, you see, the substitution has made the problem very easy and simple, and yeah, easy and simple for us to solve. Okay, you see, we started from square root of blah 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 blah. Now look at where we have reached. The problem has now become 1 over m, which is similar to something like 1 over x. So when you are to integrate 1 over x, what are you going to get? I'm just going to get what? Natural log absolute value of what? X. We take absolute value because we don't know whether the values for x is going to be negative or what? Positive. So here, what is the answer to this one here? It's going to get 1 over 2 natural log of absolute value of what? M. Good. So this is the answer to the integral question in the M world. In the M world, provided the question was a definite integral, we will not bother going back to any world again, unless you want to compare your answers. You want to find out that your answers are what? Correct. Okay, so maybe after that one, you compute the answer in the M world, also in the U world, and finally in the X world. And when all of them appears to be the same, then you can say your answer is what? Correct. But if you get one of them wrong, then you see there is problem somewhere. But here it's an indefinite integral. It's an indefinite integral, and therefore we have to go back to what? The X world. If you don't go back to the X world, maybe it can be wrong for you. Yeah, it can be wrong for you. Yeah, you can mark because I gave you X. Why are you presenting M? You can't tell me you choose M to solve the problem because so I should take M. No, if M solve the problem for you, convert that M in terms of X and then bring it back to me. Yeah, I know X, not M. So you can't tell me M is the solution to the problem. Okay, good. So here you have to go back to what? The X world. The what? X world. Okay, so going back to the X world, we know that M is equal to what? Let me write that one for you. We know that M is equal to sine inverse of U. Sine inverse of U. And also, going from U world to what? X world, we know that U is equal to 1 over 2x. 1 over 2 what? X. So I did it this way because I'm going to jump a step. That is, I'm going to jump from U world directly to what? The X world. That is why. So when you see this, M is equal to tan inverse of U and U is equal to um um 1 over 2x, 1 over 2x, then definitely M will be equal to sine inverse of what? 1 over 2x. Okay, so that is what I'm going to write in the next step. Okay, so I'm gonna get 1 over 2 natural log absolute value of what? Sine inverse of 1 over 2x. Sorry, sine inverse of 1 over 2x. So this one here is the solution to the integral problem in the X world. In the X world. You see, figuring out the approach made the problem very simple for us to solve. Doing the substitution, we're able to take away some of them, which make the problem very, 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 very simple, and even converted it to something that we are more familiar, that we have been doing in our daily life. I mean, in our daily integral problem that we have been solving, we have been encountering that problem a lot. Integral of 1 over x, integral of 1 over u, integral of 1 over p. We have been solving problem which at the end of the day giving us something like that, something of that nature. So we are more conversant with integral of 1 over p, 1 over u. We easily know answers to them. So integrating that one wasn't any problem at all. And it's all because of what? The substitution approach that we use. So when you get problems of that nature, try as much as possible to first think of the approach. The moment you figure out the approach, figuring out the approach does not mean okay, this problem I'm going to solve it with partial fraction. No, when I say figure out the approach, meaning you are to find the approach and how you are going to apply it to solve the problem. You can't say, oh, this problem, trig substitution will just work and then you just start trig substitution. No, that is not what I mean by that. If you figure out the approach, then you also find out how am I going to use this approach, because you cannot just if you don't take care, you make the problem very difficult. Though the problem was presented you in a very simple form, but if you don't know how to use your approach, you end up making it more tedious. Okay, so when you figure out the approach, then you also figure out how you are going to apply it. to make the problem very simple for you to solve. We said we are going to use substitution initially, but assuming we have substituted the u for square root of 16 minus 4x squared, maybe who knows, we could have get stuck somewhere and then trying to pick another approach, and who knows. So when you figure out the approach, you also think of how you are going to apply it. Don't just say the approach, or don't just um yeah, don't just say the approach without knowing how to apply it. Okay, how to apply it definitely depends on you. Yeah, let me say that how to apply definitely depends on you. Okay, somebody may choose to let u be equals the whole of sine inverse of what 1 over 2 what x. Now nobody cares, because the person can deal with any algebra aspect that will be what he encounters. Any complex calculation that he will come across, will be able to do it. That nobody cares. The most important thing is what, to get your final answer at the end of the day. That is what matters most. Okay, you can even decide to let u be equal to the whole of square root of 16 minus 4x squared times sine inverse of blah 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 blah. Nobody cares, provided you can deal with the algebra, provided you can compute it, you can manipulate it very well and get your answer. Okay, good. So guys, this 1 over 2 natural log absolute value of what sine inverse of 1 over 2 x is the answer to the integral problem we started solving. Okay, so therefore indefinite integral of 1 over square root of 16 minus 4x squared times sine inverse of 1 over 2x dx is equal to 1 over 2 natural log of absolute value of sine inverse of 1 over 2x, and then plus what? See, this one means it's an indefinite integral. Okay, so this is the answer to this integral question here. I believe and I hope you did enjoy the video, and if you did enjoy, please kindly give it a thumbs up, subscribe and comment. Thanks for watching, and I will see you in another video. Bye for now.